This is chapter 5 of class 9 new syllabus, exploring mixtures and their separation. So if you have to know about mixtures, if you have to know about solutions, and if you have to know different methods of separation, this chapter will give you that. Right. So let us explore mixtures in a greater depth. How can we classify mixture? Before we go to classification of mixture, what is a mixture? What is a mixture? Have you ever thought that what is the difference between a mixture and a compound? Okay, so do explore the difference between a mixture and a compound and and give me in the comment section of the video what you understood by mixture, what you understood by compound, and where is the line of difference. Now let me tell you about mixture. It contains two or more than two components. So two or more than two components when mixed in any ratio. Components mixed in any ratio. So this is known as a mixture. Mixed in any ratio is known as a mixture. Now mixture can be homogeneous and it can be heterogeneous as well. What is a homogeneous mixture? Now, if the components are completely soluble in the given solvent, then I will say the mixture is homogeneous in nature. Or rather, I can say that if the components of the mixture, they mix together in such a manner that the composition of the mixture is uniform throughout. So the composition, if the composition of the mixture is uniform throughout, then it is known as homogeneous mixture. Right? Now the question arises, how come the composition is uniform throughout? So this is an example of homogeneous mixture which is shown over here, and by this example you can see that there is no layer of separation, there is no particle separation in this particular mixture. Now why? Because I said the components are completely soluble. The components are soluble completely, and so it forms a homogeneous mixture. You can take salt and water, you can take sugar and water, and you can dissolve it nicely, and then you will get a good example of homogeneous mixture where you are seeing that no particles are remaining undissolved. Now aerated drinks like soda water, where you have carbon dioxide in water which is dissolved, they are example of homogeneous mixture. What do you think air is? This is another question to you. What do you think air is? Is it a homogeneous mixture or is it a heterogeneous mixture? This is another question that I will expect you to answer in the comment section of the video. Now, as I told you, is it a heterogeneous mixture? So let me explain what it is. Now, in contrary to the homogeneous mixture, the components in a heterogeneous mixture, they do not dissolve completely, or they do not dissolve at all. Like sand in water, will it at all dissolve? So you will have a separation of sand in water. And such a mixture has non-uniform composition throughout. It has non-uniform composition throughout. And what is the reason? Reason is they do not dissolve. The components do not dissolve. The example can be chalk powder in water, sand in water. They form heterogeneous mixture. Now there is a group activity where in chapter 5 it's the first activity or the first experiment. Now we can see there are three groups. Group A, Group B and Group C. Now Group A has added one spatula. You may think, what is a spatula? It is a spoon-like thing which is present in the labs. And there it is used to pick up the materials, the chemicals. So you can add one spatula of common salt. Common salt means sodium chloride. Common salt means sodium chloride. And the formula of sodium chloride is NaCl. Please go to see the formula, the chemical formula write-ups in the shorts also. So this is how to write chemical formula. NaCl, valency of sodium is 1, Cl is 1, so it is NaCl. Now that is something else. Now add one spatula of common salt to 50 ml of water, that is H2O, in a beaker. Stir it well. What do you think? Will it dissolve? Common salt, salt and water. Yes, of course, it dissolves. It dissolves. All of us have this experience. Now group B, the second group, they add one spatula of chalk powder. So first one, what do we have? We have salt in water. In the second one, what are we having? We are having chalk powder in water. Chalk powder in water. So this is it, and it is stirred well. Now will the second group also see that chalk has dissolved in water? Of course not. And if you have doubt, do check it out. So it does not dissolve. Doesn't dissolve. Chalk powder will never dissolve in water. Now group C has taken milk in 50 ml of water. Now this, so you have heard कि पानी में दूध या दूध में पानी. That means what? Milk is at times diluted intentionally or maybe due to some other reason. So when you add a few drops of milk to water, do you think that you can distinguish the milk from the water? So milk from water, milk is formed of some proteins, right? You can obtain casein from milk. Yes, so these all things we can see milk in water. Now what is the observation? Will you be able to distinguish milk from water? Actually not. What happens is, you think that it appears to be turbid. The solution appears to be turbid. And what is the meaning of this term turbid? Turbid. It means translucent. Translucent. It is not transparent. That solution is turbid in nature. So here in salt and water, you get a clear solution. And chalk powder in water, you get a sedimentation of chalk powder at the bottom. Sedimentation at the bottom you will see. And in milk and water, you will see the solution is turning turbid and it appears translucent. So are the particles visible in each mixture? This is the first question, and you have to observe and record. So I think when you do it, you will come up with the conclusion that, ma'am, The particles are not visible in the first group experiment where we have taken salt and water. And it is very much visible in the second case and not visible in the third case with our naked eyes. Now, direct the light from a laser pointer through the beakers containing the mixtures and observe. So what happens is, when you pass a light, you direct a light at this beaker, say you are directing light at this beaker with the help of a laser, laser pointer, you are doing it. Then what will you observe? Of course, and observe it from the side of the beaker in a direction perpendicular to the laser beam. That means if this is your beaker containing anything A or B or C, and you are passing it, projecting the laser pointer in this manner, your observation, your eye will be here. It's perpendicular to the laser beam, right? Then what will happen? Or then what will you observe? Okay, so what is the safety issue? Safety issue over here is, do not look directly into the laser beam. It is very bad to play with this laser lights and direct it at any other's eye, because it can damage your eye in such a manner that cannot be recovered. Okay, so predict what you would observe in each of the beakers if you leave them undisturbed for a minute. So what will you observe? You will observe that beaker 1 is a clear solution. Particles are not visible. Beaker 2 has a sedimentation. Particles settle at the bottom. Sand particles, chalk particles, whatever you will take will be at the bottom of the beaker. And milk, you may see some suspended particles within the entire volume of the solution. That will be your observation. As you hear to the explanation, do jot down the points whichever I am telling you. Next, set up a filtration apparatus. Filtration apparatus, for that, what do you need? You need to pour the contents of this beaker. You need to pour the contents of the beaker. Now, how? In a test tube, which has a funnel at the top. And you have a filter paper which is folded in the shape of the funnel. So you have to place a filter paper, and then you have to see whether any residue you get in the filter paper or not. So based on these observations, you have to categorize the mixtures. So what should be your observation for residue? In beaker A, there will be no residue. That means you cannot separate the components by filtration. You cannot separate salt or sugar from water by the method of filtration. In the beaker B, what will happen? There will be a residue of undissolved sand or chalk powder, whatever you have taken, because the size of the sand or chalk particles are greater than the size of the pores of the filter paper. Mark my words, size of the sand or chalk powder is greater than the size of the pores of the filter paper. So it is obtained as residue. Right? Now, when you try to filter the contents of beaker C, you will again see no residue. And you are not able to separate them by filtration, normal filtration. Now the question arises, what type of solution was present in A, in B and see in the examples that was given to you. Remember, you are going to see the things in elaborate manner later on also, that when you have seen that salt and sugar was completely dissolved, that means the components are completely dissolved, giving a homogeneous solution was homogeneous in nature, then it was an example of a true solution. This was a true solution which has which is homogeneous in nature, or which has uniform composition throughout. B was a suspension. B was a suspension. Why was it a suspension? Because the solute particles. Now here the solute particles were what? That which was dissolved in water. Be it sand or be it chalk powder. They were remained undissolved, suspended at the bottom of the beaker, and so this type of solution is a suspension. Now the third one, where it was looking like homogeneous, but the particles did not completely dissolve but was remaining suspended in the medium but not at the bottom. So this type of solution is known as colloidal solution. Colloidal solution. So you have seen what is a true solution, what is a suspension, and what is colloidal solution. Now let me tell you one more thing, that the particles of solute in a true solution, they are very, very small. The particles of solute in a suspension are larger than the pores of the filter paper, and the colloidal solution had the particles of the solute had a dimension which was in between that of a true solution and suspension. So when you see the differences, this is the first difference I will say. And what is that? It is particle size of solutes in true solution, suspension, and colloids. So next is what? Next is filtration, whether you can separate the components by filtration. So remember one thing, that for a true solution, I said what? The solute particles are very, very small. Colloid in between. So what is that dimension? Solute particles in a true solution has size which is less than 1 nanometer, 1 nm, less than 1 nm size of what? The solutes in true solution have a dimension or particle size which is less than 1 nanometer. For suspension, the particle size is greater than 1000 nanometer, and for colloids, it is between 1 nanometer to 1000 nanometer. This is the difference of the size of the particles. And you have seen that in a true solution, the particles of the solute were completely dissolved and were not visible. Whereas for suspension, the particle of solute were very much visible. They settled down at the bottom of the beaker and they were large particles. And for colloids, milk and water, the particle size is intermediate and can scatter light. I told you about laser. So when you project the laser, what will you observe? So you will see that the particles of colloids can scatter light, which is known as Tyndall effect. Which is known as Tyndall effect. So explore more about Tyndall effect, and I will give again more videos explaining the difference of these three. So Tyndall effect means scattering of light by particles. Scattering of light by suspended particles. By suspended particles in a solution. Right? So Tyndall effect was seen in colloids, but it was not seen in other cases. Milk, fog, colloidal solution. Another example is fog. Fog is a colloidal solution. Okay, so now what happens over here is that when you try to filter them, then what happened? True solution, you couldn't separate the components. Suspension, you could. Colloid, you couldn't, right? Now, you know what is the natural way of seeing Tyndall effect? When you enter a dusty room and the sunlight reaches the room through a slit in the window, don't you see suspended dust particles? Why, you know? These suspended dust particles, they scatter the sunlight which is projected, and this phenomena of scattering of light by particles is known as Tyndall effect. You see in forest also, true solution, you don't see Tyndall effect, right? You see Tyndall effect in colloids, you see Tyndall effect in suspension also, because the particles are large in size. So Tyndall effect you can see in colloids, you can see in suspension, and you will not be able to see in true solution. In true solution, there is no Tyndall effect because the particle size are so small, they do not show Tyndall effect, right? But the colloidal particles are large enough to scatter light, and so they show Tyndall effect. But keep in mind, suspension will show, the particles in suspension will actually scatter light more. It will show more Tyndall effect than colloids, right? So next, moving to concentration of solution. What do you mean by the term concentration? Concentration actually means how much of the solute is present in a solution. So the term concentration is the amount of solute dissolved in given amount of solvent or solution, that is known as concentration of the solution. So what I said, the amount of solute dissolved in a given amount of solvent or solution is known as concentration of the solution. That means in a fixed amount of a solution or solvent, how much of the solute is dissolved. I hope all of you know about ORS. ORS, when you have tremendous dehydration, this oral rehydration solution is given to you. What is the full form of ORS? Oral rehydration solution. Now, keep in mind that when we add specific amount of salt and water to a fixed amount of water, then only we can get ORS. At home, when we try to dissolve salt and water in any amount, then it is not the ORS which we are talking about. Oral rehydration solution has a fixed ratio, has a fixed measurement. Not all sugary drinks prepared at home or in the market are ORS, right? So ORS has a fixed amount of salt or sugar added in a fixed amount of water. Now, if you change the volume of the water, or if you change the amount of salt and sugar, then it will not remain ORS. Similarly, the pesticides that the farmers use, they also contain a right amount of water to prepare the solution of the pesticide to make it effective, Too little pesticide may not protect the crops, and very much of it will cause environmental hazards, right? Now, this is some information which is very, very important and you should know as an Indian. Dilip Mahalanabish, it is known as Mahalanabish. So, Dilip Mahalanabish is an Indian pediatrician, right? And he first developed and implemented the treatment for dehydration in diarrhea, in cholera cases, and he formulated the ORS that we know as the rehydration therapy. It has saved so many lives after WHO, World Health Organization, made it popular worldwide. Okay, so this was the contribution of our Indian pediatrician, right? Now, what are the terms by which we can express concentration? We can express concentration in terms of mass by mass, in terms of mass by volume, and in terms of volume by volume. So, elaboration of this topic will be in the next video. Till then, bye all of you.